Hello, welcome back. Today let's try to solve another Leetcode problem. Actually, this is also similar to the Leetcode daily challenge problem. 26 maximum caddies allocated to K children. So the problem is that we are giving a array. So inside an array is a pile of caddies. So for the first one, we have 5 caddies, and the second pile have 8 caddies, and the third pile have 6 caddies. And also for each of the pile, it can be divided into 2 or many piles. We're just gonna check if we can find k at least k equal piles. So this means if we can find at least k piles of caddies, each of them have the same number as 5. So this is the first example. So for this one, we can divide the caddies index 1, this 8, into 2 with 5 and 3. And for caddies 2, we're gonna divide it into 5 and 1. So we're gonna find this 5, 5, 3, 5, and 1. But what we needed to do, we just needed to find more than 3 or equal than 3 piles of caddies which have the equal number. So this number should be the biggest, so it should be 5. So we're gonna return a 5. So for such kind of a problem, normally if we are giving an array and with this k is a threshold, or just needed to distribute it to k children, normally we need to check the length of the array. It is 10 to the power of 5, and then we're gonna just check the caddies and the k's. So this is easier for us to check whether we are going to use DP or other algorithms like greedy or binary search. For such problem, normally we use binary search because we're gonna check the maximum number of caddies each child can get. So for such problem, and there's also at most 1 piles of caddies. So there is also an integer k. So this k means you should allocate piles of caddies to k children. So this means you should find at least. So this means you need to find at least k piles of caddies, and these k piles should be equal to each other. It means always have the same numbers of caddies, and these k piles should be distributed to 3 children. So for such problem, normally we're gonna use a binary search to guess. Because if you did the daily challenge of today's Leetcode problem, normally you can find a solution for this one because it is easier than today's challenge problem. Now, for this one, we're just gonna guess a number. For example, if we guess a number of 10, is that 10 possible? It's not possible. We cannot find even a number that is bigger or equal than 10. So what about number 4? 4 is possible because 5 is more than or equal to 4, 8 is more than or equal to 4, 6 is more than or equal to 4. We can at least find 3 piles of caddies that is equal to 4. So 4 is a possible result. If 4 is a possible result, what about 5? Is that 5 okay? Yes, it is, because according to the example, it is okay. So how should we find this number? Normally we can guess, but how can we guess it? We can use a binary search to guess if we know the minimum of the number and maximum of the number. So what is the minimum? So the minimum means, so what is the minimum of piles? It can be 0, because for example, this one is 0. If we only have 2 piles and the sum of them is even less than the number of children, it means we cannot even distribute 1 caddy to each of the children. That is not possible, so we're gonna return a 0. So this means the minimum number of the caddies of the piles should be 0. So what is the maximum? So the maximum should be 8. Because we cannot find a number that is bigger than 8. So for example, that is the number 10. 10 is even than the biggest numbers of the pile. 10 is even less than this 8. It means that is not possible. So it has to be 8. So from 0 to 8, we're gonna define our binary search boundary. So the L and R should be 0 and 8. But here I'm gonna use 1 because if I use 0 for for my checking function, I will get an infinite loop because I cannot use numbers divided by 0. So here, let me prepare the check function first. So inside the check function, it would be a threshold with the k value. So this is basically a template. I will write this later. Yeah, but inside it's not a template. But for the binary search, actually it is a template. So what is the R? It is the maximum of Candies. And the result should be 0. Yeah, so here I use result as 0. This means if I didn't find, I can still return a 0. So this means I can still return my result. Yeah, but for the L pointer, it should not be started from 0. It should be started from 1, because later on I will use my values count divided by the threshold. If the threshold is 0, I cannot calculate. Yeah, use the division. Now let me write the binary search first, and then I will write the check function. Normally this is my template for solving such problems. So now let's write the binary search. So for the binary search, it should be L less than or equal to R, and then I'm got a M. So what is the mid number in between the smallest and the biggest? It should be L plus R minus L divided by 2. Now I'm going to check if I can find a threshold. So here I use M and with K. Yeah, if I can find a threshold, this means, for example, if this number is let's find a number. For example, this number is 4. Yeah, so if 4 is a possible result, what I'm gonna do? So maybe 5 is a possible result. Yeah, so I will get my result as the M, and then update the pointers. So the L pointer actually should be M minus 1. This means if I further check, this M is 4, so the threshold is 4. 4 is a possible result. What should I do? Maybe the next number may be a possible result. What about 5? What about a bigger number? So here I use the L pointer equal to M plus 1. Else, if I didn't find, so the R pointer should be M minus 1. Yeah, because if I guess a number that is too big, for example, this number is 10. 10 is not possible. So what about a smaller number? So the R pointer should be shifted to M minus 1. Yeah, and then I will return my final result. So here I will write the check function. Actually, the check function is much easier. Yeah, if you find the solution, we're going to use a binary search. So I will define a variable as a count. And now I'm going to loop through the Candies. So for C in Candies, if this C is more than and equal to the threshold, yeah, so here, what I mean by this, I mean if this 5, the threshold is 5, if this 5 is more than the threshold, so I'm gonna count my numbers. Yeah, so I'm gonna count. So from here, I'm going to use the C divided by the threshold. Why? Yeah, because if this number is too big, for example, this number is 10, I can even distribute it to 2 piles. Each of them will be 5, a possible result. So this is why I'm going to use division, C divided by threshold. And the code should plus this number. The code should not plus 1. It should be plus divided. It may be 2 or more numbers. So this is why. Yeah, I also make a mistake when I use the code plus 1. I also make a mistake when I use the L pointer as 0, because the threshold, yeah, the M can be a 0. If the M is 0, the threshold is 0, and here we'll get wrong. So this is why I'm gonna start from 1 to the maximum of the Candies array. Yeah, and then I will define my result as 0. Yeah, because even it is not inside this range, the 0 will be my result. Yeah, for example, this one. So this is why I define all those variables and write all those functions. And now, for the final step, we're just gonna check if this count is more than and equal to the number k. Yeah, basically the template for such problems, yeah, basically it's like the allocated to k children maximum or minimum problems inside an array. You're gonna first think about the binary search. If we can use binary search, it's just a guess. We can guess one by one, but here it is a guess only log m. Yeah, if the maximum number is m, we're gonna guess log m. And what is here? It is only on. So the time complexity is n times log m. Now let me just run it to check if it really works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases and it's pretty fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. Thank you.